Alright. CIS-125. This is day 13. This was last week. So it would have been the 12th. Alright. Start talking about iterations, creating a loop. So we're using the same example. We got the farmer, except now he has an unknown number of boxes he wants to make. So how much paint will he need? So paint will he need? So let's, he has a box here, he's marking out his fields. And so we don't know how many he's going to make. So somewhere at the end we'll have what we call flag the data. We mark the data in order to stop our loop, because what we're going to do is we're going to do the first one, then we're going to loop and do the second, and then the third, and then keep repeating the process until we finally reach the end, and then we can indicate how much paint we need. Look at the flow chart. So not everything's here, okay, so I don't have everything, but I have the start. Total paint 0.0, so that we have a float, right, a real number. We input the length and the width, and then we check. We're going to flag the length with 0. With 0. More or less, as long as the length isn't 0, we're going to keep doing the loop. So we're going to check that right here. We have a while statement. True, or yes. We're going to input the width, calculate the perimeter, total the paint. So here, if you notice right here, we got a variable total paint. It was 0. We're going to take the gallons and add it to 0, and then store that over here. So every time we go by this box, it's going to add up the paint. We're going to get a sum of how much paint we need. Now we're input just the length, and then we got a message in here, end with 0. So let's track this back up. Okay, as long as it's greater than 0, we go in, we process everything. Here we do a sum again. So we keep adding the gallons into the total paint, get the length, go up. As long as it's greater than 0, then we get the width, and we just keep going. So we could have an infinite loop until we reach flags. When we want to stop, we put in 0 for the length. This becomes false. We come over and we print out our total paint. And end. So we have our process in here, and then we just loop and keep doing it until something causes us to stop. To look at the legend here, I put the flag in there. We're going to flag length as 0. And I also put in there, we're going to sum up the amount of paint. So we added those to the previous legend from the problem before. Again, you could follow it here. Enter the length, check the length. If it's greater than 0, we're going to process, sum up the paint, get a new length. As long as it's not 0, get the width, get the perimeter, sum up the paint. And as soon as we enter here the value, the length, as soon as we enter 0, this is going to become false, and then we're going to finish. Of course, we're going to give you a pseudocode. This is pretty close to Python. We got a start and a stop. and we got some lines, and then we initialize the paint, we input the length. While length is greater than 0, I got my colons, and then it's going to perform everything that's indented. So we're going to input the width, calculate the perimeter, get our total, input the length, then it goes back up and checks. So we come down, back up, and then when the loop's done, when this becomes false, it comes right to this line here, and then it prints out the information we need and it stops. You notice that has to be indented. In your pseudocode, if you put an end do in here, that'd be okay too, just so you could see it. Okay, so then for loops, if it's a leading decision, you'll always have a connector. You'll have that decision. The true part will keep you in the loop. The false part gets you out of the loop based on this conditional here. Do your processing, come back up, and somewheres in here you would have to cause this to become 0. Alright, that's it.